Graphs of secant and cosecant. So here we got our unit circle right here. It's important that you memorize this, guys. This will be more helpful if you can have this memorized. So what do we have on here? We have our exact values. We have our radians and we have our degrees. And it's just like the Cartesian coordinate, right? You have your X and your Y plane. Oops. Axis. Okay, so it's important to know all these points where they fall out on this graph. So the first question says, find the exact value of the expression of the cosecant. So to find the exact value of the given expression, we're going to use the unit circle to identify the sign. Why did I say sign? Well, because I know that, well, let's just talk hang a second. So sine of some angle equal to y, because sine is the y value, and cosine of some angle equal to x, because cosine is the x value. So now we're going to look at the point where the alpha here is equal to that negative pi over 6. And the unit circle is, again, with the order pair of cosine of alpha equal, or comma sine of alpha. So when we go over there, we can see that pi over 6 is in the first quadrant. So here it is. The negative tells me we went around this way to get to it. So the expression is negative again. So what we're going to do is let's rewrite it. Well, I'm going to use sine because I know that cosecant is the reciprocal of the sine. So let's write it out. Cosecant of the negative pi 6 is equal to 1 over sine of negative pi 6. Well, when we go over there and look, what do we see? We got that half for the sine value, but remember we had to go around the other direction, so we still have a negative value. So I got this. Now I'm just going to rewrite it where it's more durable or easier to work with. And whenever we divide by fractions, we're going to keep, change, flip. So let's keep the first. We're going to change the second. And now we're going to multiply it, which gives me negative 2. So that is my value. Okay. So now let's go to the next one. We're going to find the approximate value of the following expression. So we have secant 1.35. So what do I know about secant? Secant is the inverse of cosine. So let's rewrite it. I have secant of this alpha is equal to 1 over cosine alpha. Now let's just plug in what we know. The secant of 1.35 equals 1 over cosine of 1.35. We're going to type it in our calculator. We're going to round to the nearest tenths. We get 4.6. Okay. So now let's look at number 3. Number 3 says determine the period of the function. So we're given this function right here. Y equals cosecant 5x over 7. So what do we know? Cosecant is the inverse of sine. So let's just write it. We have cosecant of 5x sevenths is equal to 1 over sine 5x sevenths. All right. So we know that much. So we remembered it. Well, let's talk a little bit more about the actual finding of the period. We know that we have this formula, right? And we look at the B, right? Because that tells us what the period is. Remember, the period has a formula of 2 pi over B. So what is B? Well, B in this case is 5/7. So let's rewrite it. And of course, we're going to keep, change, flip. And we can't reduce, right? So we're just going to multiply straight across, 14 pi 5/5. And that is the period for this function. Now, I just started off with this because I want y'all to keep remembering secant, cosecant is inverse of sine, and secant's inverse of cosine. So I'll just keep reminding you off and on. All right. Got one more. Let's talk about it. Determine the range of the function. So first, when you you will need to find the graph of this function right here. All right. So because secant is 1/2 cosine, right? Secant is right. So since that is, we're going to transform about the cosine. So we're going to take the original cosine. We're going to transform about that. Okay. So now when I do that, I got this. And we're going to notice that it stretches the graph vertically up by 6. Let me write it down right quick. Stretches the graph vertically by a factor of 6 right here. The amplitude, remember? Okay, so since the coefficient 6 is positive, we do not reflect on the graph. If it was negative, that means it would reflect on the x-axis. So let's see if I can get this going, looking. Okay, so, okay, very good. Now we have, this is my cosine x. So what I'm going to do now is I'm going to start applying what I got here to my graph. So we're going to take this graph and we're going to stretch it again 7 units, or so, excuse me. Let's see, we're going to stretch the graph. Okay, 6. And once we do that, let's look at it. And y'all can use y'all's graphing calculator. And it actually, you know, it's just you need to use a graphing calculator to get a really good shot of this. All right. So what do we know? When the denominator is smaller than the numerator, the outcome will be larger. So how am I saying this? I'm taking the 6 secant from original, setting it equal to 6 over my cosine because it's the reciprocal, right? So now I'm looking at it. Whenever the denominator is smaller than the numerator, the outcome is larger, okay? So in this case here, 6 cosine x is larger. That means 6 secant is bigger than the cosine. There will be a vertical asymptote wherever this y equals 6 cosine x is equal to 0 on the interval of 0 to 2 pi, which makes sense when we talk about the unit circle 0 to 2 pi. All right. The y equals 6 secant x vertical or gas vertical asymptote will give us a pi 2, 3 pi halves is equal to the 0. So you can, like I said, you can check it on your graph. But whenever you come and look, what you're going to see, because the amplitude here tells me my range, right? Because you're going to have this graph that goes up to a certain point and down to a certain point. And this particular one, though, since we have the type of graph, we have this, and it's going to hit 6 and -6. So I know my range. We got, oops, erase this. And since it's continuously going on, and it's not one, look, you notice there's 2 here, right? Oops, I started it out. 2 here. So we know that we're going to have negative infinity, because we're talking about all the negative infinity values here down at the bottom to the -6. We're including it. And it's going to union to the +6 here to the positive infinity. And guys, always put a parenthesis on infinities because we can't stop infinity. But 6, we're going to put a bracket because we're actually stopping on that point. And that is my range.